Hi everyone, welcome back to Leetcoding. I am Faraz and today we are solving the Leetcode contest 246 and we are going to solve the problem number 4. So the problem number 4 was also a medium problem, but it could be solved using different strategies, different approaches, and it was actually a tricky problem. So let us see how we can solve this. Let me just minimize this. Okay. Yes, I think it is fine. Alright, so let us read the problem statement. Minimum absolute difference queries. So the minimum absolute difference of an array A is defined as the minimum value of AI minus HA. You can read the problem statement. I will just explain you what the problem statement is saying. So basically we are given an array, then we will be given some set of queries, and in those queries we will be given two indices, Li and Ri. So we have to tell the minimum absolute difference starting from Li to Ri. Alright, for example, like this is the given array 1 3 4 8, and if the query is 0 and 3, so that means starting from 0 till 3 you have to tell the minimum absolute difference between any two pair. Similarly, if we have 1 and 2, then in 1 and 2 we mean starting from 1 ending at 2. In these two elements find the minimum absolute difference. So the answer in the last case, in which we are given 0 to 3, the answer is 4 minus 3, that is 1. That is the minimum absolute difference. Okay. Now if two elements are same, then in that case we have to return a -1, because we cannot have the absolute difference as 0. It is mentioned in the question itself. That is the corner case over here. This note that 0 is not 0, because AI and HA must be different. Okay. All right. Yeah, if all the elements are same, then we will have to return -1. But let's say if two elements are same, 2 and 2, then although the minimum absolute difference is 0, but in this case we will not consider them as two different elements. So that is why we cannot subtract 2 from 2. We will be subtracting 3 from 2. So that is 1. In case when all the elements are same, then we have no option. Then in those cases we have to return -1. Now let us see, starting from the very brute force approach, that how we can solve this problem. So the first intuition that comes to our mind is like we have this array. Let me take the second example over here, and I'm sorry for the background noises if you can hear any, because it is morning and everybody is, I don't know what they're doing. So like if this is the given array, and in this given array we have some queries. Let's say we get a query starting from here to this point. So we want to find the minimum absolute difference starting from this particular point to this particular point. So what we can do is we can take all these elements and then sort them. So 2 2, these are already sorted luckily. So 2 2 7 10. Now the minimum absolute difference could be find out by comparing the two adjacent elements. That is a fact, you know. I think you can just realize it with an example maybe, or let me give you a counter example. So let us say that if this is not sorted and two elements are adjacent, then in that case that difference will not be the minimum absolute difference. For example, if 2 is adjacent to 7, then the difference is 5. Obviously this is not the minimum absolute difference. Okay, the minimum difference will only be when the two adjacent elements are sorted. So if we sort the entire array, we can find the minimum absolute difference by just comparing the two adjacent elements. So in this case it is 0. In this case it is 5. In this case it is 3. 0 is not allowed. 0 is not allowed. So 3 is the answer for this particular query. Okay. So for each query, what we are doing? For each query, starting from Li to Ri, we are sorting all the elements which are being covered by that query. Like let's say if we have a query from here to here, we will have to sort all these elements. So 2 2 5 7, we will get this as sorted. So what will be the complexity of the solution? What do you think will be the complexity of the solution? Let us say we have m queries, and let us say we have n number of elements. So for each query, that is m multiplied by, for each query you will have to, in the worst case, the query might be covering the entire range. Okay, so in the worst case you will have to sort n elements, so that will be n log n. So m into n log n, this will be the time complexity for the solution. No extra space will be needed. Extra space will be needed if you just like take those elements into another array, but I think you will have to take those elements into another array, because you cannot disturb the sequence of this array. Okay, so I think you will have to use some auxiliary space big O of n each time for each of the queries. Alright, so big of n space complexity, this will be the time complexity. This is the solution number 1, which is going to give us TLE, because these two constraints are very high and this will never pass in 1 second. We have to pass the solution in 1 second if you don't know. So these are not, this will not allow us to pass. What is the maximum that we can get passed is 10 raised to the power 7, but this will be 10 raised to the power 4. M is given as 10 raised to the 4 number of queries. You can just check it out by yourself, multiplied by n log n. So n will be n is 10 raised to the power 5, so 10 raised to the 5 multiplied by log. This is more than 10 raised to the power 9, so that is going to give us TLE. We should take it down to somewhere around 10 raised to the power 7 to get it accepted. So this is the first solution which will give us TLE. Now talking about the second solution, let us move forward. And so before we move ahead, let us talk about interviewing.io. Interviewing.io is a platform where you can practice realistic coding interviews with interviewers from Google, Facebook, Microsoft, Amazon and other major tech giants. And they will give you a detailed feedback on the areas where you have to work. And the best part about this is you don't have to pay them anything until you are hired. They have the world's largest network of interviewers from these companies, so you can get your interview scheduled with a notice of 24 hours. So if you are preparing for any such company, you can definitely check out interviewing.io. The link is in the description. This is what is given to us. Now this is 0 index, 1 index, 2 index, 3 index, 4, 5. Okay. Now what we can do is we can create an auxiliary array. Now this array will be sorted, and we are going to use these indices to sort them. So let me just give an example. So what is the smallest element here? It is 2. Okay, it is 2. So the index of 2 is this 2. So 2 will come here. This index, we have to take this index here. Then next smallest element is again 2. Then the index is 3. So 3 will come here. Next smallest element is 4. The index is 0. 0 is going to come here. Then the next smallest is 5. The index is 1, so it will come here. So actually we are just sorting the array, and while sorting we are storing not the element but the index of that element. I think it is clear to everyone. Then 7, the index 7 is 4, then 10, index is 5. So this is the second array that we created. Okay, now how can we answer the queries in this array? Like let's say the query is from L to R. Let me take L to R as 1 to 4. If the query is from 1 to 4, then how can we answer this query? So we will start from the beginning, and we will see that if these two elements are falling within the within these range, 1 to 4. So 2 and 3, yes, it is falling well within the range. 2 and 3, these indices are falling within the range 1 and 4. Actually we have to consider this part 1 to 4, and this 2 3 is falling inside this. So we can take the absolute difference of whatever is stored at index 3 and whatever is stored at index 2. I hope you are getting this, because these two are in increasing order. So at 3 it is 2, at 2 it is 2, so 2 minus 2 is 0. The absolute difference is going to be 0, but 0 is not considered as an answer because the two yeah, it is not allowed by the question. So moving ahead, comparing these two, 3 and 0, are these two within the range? No, it is not, because 0 is on the left hand side of 1, so this is not in the range. Ignore this. Again this will be ignored. 0 and 1 will be ignored. Then 1 and 4, 1 and 4 is well within the range. So whatever is there at 4, 7 is there at 4, whatever is there at 1, 5 is there at 1, so 7 minus 5, it is 2. So the answer will be updated to 2. Next 4 and 5. So 4 and 5 is not falling within the range because 5 is on the right hand side of 4. So I think 2 is the answer in this case. We can just verify it from this. Oops. We can just verify it from here. So I think 5 minus 2 is 3. This is not 7 minus 5, 2. 2 is the answer in this case. The maximum absolute difference between in this subarray is 2. So we got the right answer. So what we are doing is we are creating this array, as I told you the steps to create this array. Then after creating this array, this is actually in increasing order. This array is sorted in increasing order, but instead of storing the elements, we are storing the indices of those elements. Okay. Now after that, we are just comparing them because it is sorted. We're just comparing them one by one, adjacent. But while we are comparing, we just have to check that if these indices fall within the range of L and R. I hope it is clear, and let me just explain you the complexity of this. So creating big of an extra space to create the auxiliary array. This is the space complexity. Talking about the time complexity, let me just think of it. For each of the query could be as large as big O of n. So there are m queries, and each of the query could be as large as big O of n, and it doesn't actually matter that what is the size of the query, but Each time we have to traverse the entire auxiliary array that we have created, that is of size n, so big O of n. So that will be big O of m into n. This will be the time complexity of this solution, big O of m into n. So this was the second approach, which is again going to give us TLE. Why? Because this will be 10 raised to the power 9. It is better than the first one, but it is still not acceptable. Now let us talk about the third approach, which is quite creative and which is quite tricky to come up with. But if you have enough practice, you can come up with these kind of approaches during your interviews or maybe your online assessment rounds. So let us see what that approach is. For that, we will just have to jump here and see the constraints. See, this is the main part. Here it is saying that the number of I, that is those numbers which are given to us, these numbers, the range is from only 1 to 100. Okay, the range is very less, from 1 to 100. Now what we can do is, for each of the query, yes, what we can do is, here, let's say if this is the array which is given to us, this is the nums. Okay, this is the nums array which is given to us, and in this nums array, this place could hold elements starting from 1 to 100. This place could hold elements starting from 1 to 100. Like this is the range of the elements which we have. Same for this, all the places. Now let us say we are given a query, and the query is from here to here. Now what we can do is, we can keep a prefix sum of all the values. Okay, we can keep a prefix sum of all the values which are present at the indices which are previous to this. I know that it is not entirely clear to you, so I'm gonna take an example. So let us say it is 1, it is 2, it is 2, it is 3, it is 6. So here we will be storing the frequency of 1 as 1, the frequency of 2 as 2, the frequency of 3 as 3, the frequency of 6 as 1. So this is the frequency we are keeping. So we will be keeping a frequency from starting from 1 to 100, 7, 8, 9, 10. For all these it will be 0, 0, 0, 0, 0, 0. So we will be keeping frequencies. And let's say if we want to find out the answer for the query L and R. So what we are going to do is, we are going to subtract the frequencies of L minus 1 from R. So frequencies of R minus frequencies of L minus 1 is going to give us whatever is there in the range L to R. Okay, for more clarity, for those who are looking at this approach for the very first time, let me just explain you. So let us say this is the index L, this is the index R, and till the index L we have some numbers. Let us say 1 is coming 4 times, 6 is coming okay, we'll have to go sequentially, 2, 3, 4, 5 till 100. Okay, so this is coming 0, 0, 0 times, 2 is coming 7 times, 3 is coming 1 time, 4 is coming 2 times. Okay, this is for L. Alright, and similarly if we have something like this for R as well, so 1 is coming 5 times, let us say, 2 is coming 7 times, 3 is coming 2 times, 4 is coming 3 times, and so on. And let us say 100 is coming 1 time, and all the other elements are coming 0 times. Okay, now we want to find out what elements are there between L to R, including L and R of course. So we will see what is there behind L. Okay, what is there behind L, because we want to include L, so we'll see what is there behind L. Let us say the element which is present as L was 4, so here it will be 1 3 times, 2 7 times, 3 1 times, 4 2 times, other elements 0 times, and 1 will be coming 3 times, because when it will come to L it will come 4 times, because L is containing 4. Okay, I hope it is clear. So whatever is there at R, this will be subtracted from this. So for 1, 5 minus 3, 1 is occurring 2 times. For 2, 7 minus 7, 2 is occurring 0 times. For 3, 2 minus 1, so 3 is coming 1 times. For 4, 3 minus 2, that is what, 1, 4 is coming 1 time. Then 100, 1 minus 0, 100 is coming 1 time. Other elements, other numbers are coming 0 times. Okay, so we created an array. What a nice array I have created. So we created an array starting from 1 to 100, and this will contain these values. So 1 will be containing 2, 2 will be containing 0, 3 will be containing 1, 4 will be containing 1, 5 will be containing 0, so on, 100 will be containing 1. So this is what we have created. Nice, you got this. How did you get this? You get this by subtraction. I hope you understand this. Then after this, what you can do is you can just simply compare the two adjacent indices, like the frequency of 2. Yeah, so what you will have to do is you will have to start from here, and starting from here, whatever is non-zero, so this is non-zero, this is 3, and this is also non-zero, this is 1, so 3 minus 1 is 2. 2 is one of the option. Then you will have to go beyond this 3. Then you will see what is the next non-zero. Next non-zero is at 4, so this is 4 minus 3, which is 1. So 1 will be our answer now. Then after this, you will have to compare, like you will have to keep comparing for two adjacents which are non-zero. Okay, two adjacents which are non-zero. You just have to subtract the difference between these. Okay, that's it. Not the frequencies, not the difference between the frequencies which we are storing, but the difference between like the indices of this array. Okay, so this was the approach number 3. Now let us talk about the space and the time complexity required for this. So let me just create a matrix that we need to create here. Okay, so let us say these are the numbers at the index 0, at the index 1, 2, 3 till 10 raised to the power. This is the worst case that I'm taking, 10 raised to the power 5 minus 1. This is the index. Okay, now for each of these indices, what we are doing is we are creating a list starting from 1, maybe a frequency map or a list or whatever you say, starting from 1 to 100. So for 0 also we are creating a list starting from 1 to 100. So it will be 1, 2, and if you are confused of the indexing, it could be 0, 1, 2, so on till 100. Okay, this will just count the frequency, prefix sum of the frequencies. Similarly for this, so in the worst case, it is going to be 10 raised to the power 5 multiplied by 100, which will be 10 raised to the power 7 in terms of space as well as in terms of time. Okay, so this is the space and the time to compute this matrix. Once this matrix is computed, now you have to answer each of the queries one by one. So there are m queries and m is 10 raised to the power 4. Now once this query is coming, what we have to do is we have to, let us say the query is coming between these two indices, like this is the index 10, this is the index 2, maybe 1. So the query is coming, okay, yeah, so the query is coming from 2 to 10. Then what you have to do is you have to pick up this frequency, prefix frequency summation of the 10th index and subtract the prefix summation frequencies of the first index from this. Why first? Because first is like we have to take into consideration the second index, so that is why we have to subtract the first index. Basically what we are doing is like these frequencies, these frequency prefix frequency table, this one, these columns are actually having all the frequencies starting from here, from the top till this position. Like this one is also having starting from here till the top, but we only need starting from here till here, so that is why we are subtracting whatever is there above this. We are just removing this part. Okay, so in other terms, let us say if I want something from here to here, and if I have something from here to here, and if I have something from here to here, and I want the answer for this part, then what I will be doing, let us say the value of this is y, the value of this is x, I will be doing y minus x. Fine, then I will be getting this part. So the same thing we are doing here. Now to compute each of these queries, it is this multiplied by 100. Why? Because it will be taking time of 100 in, like if you want to subtract this particular row from this row. I hope you understand this. So this will be 10 raised to the power 6, the maximum will be 10 raised to the power 7, and it will get accepted. So this solution will be accepted in this case. Okay, so this was the third solution which will be accepted very easily. You can just code it out, and now talk about the fourth one. Now the fourth one is a bit tricky, and I know many of you won't be able to like actually code it out. Like you can just come up with the concept. Of course the concept is easy, it is simple, but when it comes to like coding it out, then it will be really difficult to code that, because we have to implement binary search tree, and in that binary search tree we also have to handle the rotations in order to balance that BST. So that is a complex part. So let us say if you create a binary search tree on the basis of the indices, so let's say you have 1 2 0 1 2 3 4 5, these are the indices maybe, Okay, these are the indices, and if you create a BST, this is the BST, the balanced BST I'm creating. Okay, 3, then 2 is gonna come here. No, not 2. 1 is gonna come here in the balanced BST. 1 will be here. So 1 will be here, 2 will be here, and 0 will be here. And here it will be 4 and 5. Okay, this will be the balanced binary search tree that you will be creating out of these. Now, what I want is, let's say I want the answer from 1 to 4. Okay, I want the answer from 1 to 4. Then what will I do? So to find the answer from 1 to 4, I will come here and I will see that what is the range on the right hand side of this. So it is from 0 to 2. On the left hand side of this is from 4 to 5. Okay, now I want the answer of the range 1 to 4. Now for that, what I will do is I will just split it. Okay, I'm gonna split it into 2. So that will be finding the answer from 1 to 2. Okay, starting from 1, this left boundary, to 2, and finding the answer from 4 to 4. Like we will have to, from this side we will get the answer from 1 to 2, from this side we will get the answer from 4 to 4. 3 is already there. Okay, so now again, like for this particular subtree, we are getting a query of 1 to 2. Now when we are getting a query of 1 to 2, 1 is already there. So from the left hand side, this is not required. From this side, we need the answer from 2 to 2. So this is going to give me the answer, and similarly I will just compute the answers. Now how are we going to compute the answers? So let us say this is the node and these are the two subtrees. Now this subtree is going to return 3 values. The first value is going to be the, let's say this is the left side. So left side, minimum absolute difference. From the right side, minimum absolute difference. Okay, this is the minimum absolute difference on the left side. This is from the right side. Now after this, there are 2 other things that are required. That is the left side maximum value and left side minimum value. From here it will be right side maximum value and right side minimum value. Okay, now for this particular node, the minimum absolute difference will be, for this particular node the minimum absolute difference will be either this from left side, or this from right side, or it can be, let's say the value of this is v. So, or it could be v minus maximum from left sides, v L max, or it could be right minimum minus v. 2 options, these and these are the 2 options. Like in out of these 4 options, one will be the maximum minimum absolute difference for this particular node. Okay, and now this node in order will return the minimum absolute difference which we just computed, and the minimum value will be the minimum from the left side, and the maximum value will be the maximum from the right side. So these are the 3 values that it will return in turn. So this is how you can compute it, and those who have solved these kind of questions using segment tree or maybe a BST knows that how to just go and solve these. But this is going to be really tricky when you try to code this out using BST. If you use segment tree, it will be simpler, but BST is going to take a lot of time and it will be much more complicated. So I think the third approach was much better than all these. Time complexity will be log of the range that we are getting. So it will be log of m queries and log of n. N is the number of nodes. So m into log n will be the time complexity for to compute all the queries. So I think this is the best approach. Also, like in the third approach, we saw that when we were creating that frequency kind of thing, frequency table, prefix sum frequency table, then we need because we could do this because the range of nums of I was given as 1 to 100. Now if the ranges are out of these 1 to 100, maybe let's say 1 to 1000 or 10 raised to the power 9, then this approach is not going to work. Then we will have to come up with the BST or the segment tree. Okay, so this 1 to 100 range helped us a lot. Alright, so I think this is it for the solution. If you like the video, make sure to subscribe to the channel and hit the like button. Alright guys, so see you in the next video.